By the time the web becomes mainstream, GIF already feels inevitable. The same file extension appears in export menus, browser source code, clip art disks, and page layouts across millions of sites. What almost none of those interfaces show is that the format's most useful feature, its compression, carries a licensing risk. A .gif icon in a file manager looks harmless. It is small, ordinary, and everywhere. Somewhere behind it sits a patent claim that most people shipping the format have never read. Why that matters starts earlier, in an era when transmitting a single image is expensive. In the late 80s, most personal connections to online services run through telephone modems. A 14.4 kilobit line turns every extra byte into waiting time. Downloading a full-color photograph at screen resolution can mean minutes of progress bars. Storage is limited, bandwidth is slow, and every online service from CompuServe to bulletin boards needs a way to move pictures in compact form. The environment demands a format that compresses well, meaning it shrinks file size by finding repeated patterns in the data and decodes simply on the other end. Limited color depth is acceptable. A fixed palette of up to 256 colors, a grid of preset shades, fits most of the graphics people actually exchange. Logos, toolbar icons, navigation buttons, small illustrations. The format that fills this role uses a compression technique called LZW. Software makers build support into their export menus. Web graphics handbooks print tutorials around it. Browser developers include it in their rendering engines early. The .gif extension becomes so ordinary that it disappears into infrastructure the way a wall socket disappears behind furniture. That ordinariness is the precondition for what comes next. LZW compression was covered by a patent held by Unisys, and for years the implications remained mostly invisible. Early adoption happened without widespread awareness of the licensing terms. Small developers, freeware authors, and bulletin board operators were not reading patent filings when they added GIF export to their tools. The format spread precisely because no one treated it as legally encumbered. Then, in the mid-90s, Unisys began asserting licensing requirements. The details varied, but the operational consequence was consistent. Software implementing GIF support now faces licensing exposure around the patented LZW method, especially for commercial distribution. For a hobbyist building a small graphics tool, the question shifted from, can I support this format, to what happens if I ship it? For browser vendors distributing to millions of users, the calculus became sharper still. A licensing notice tucked into release notes, a legal disclaimer appended to a README file, a warning, added to a software installer screen. These became new artifacts in the packaging process. Some projects went further, removing GIF writing support entirely to avoid entanglement. The format had not changed. The files still looked the same, but the risk profile of shipping them had changed entirely. This turns a file format into a distribution risk. A supported formats list inside a software manual is an economic document as much as a technical one. Each line represents a format someone judged safe to ship. The response from the web development community is structural. A group of engineers and standards contributors begins work on a replacement, a new image format designed specifically for web graphics needs, built on compression methods free of known patent encumbrance. The format is called PNG for Portable Network Graphics. Its design goals reflect lessons drawn from GIF's constraints and from the licensing crisis itself. PNG moves past GIF's 256 color ceiling, supporting a far wider range. It handles transparency differently. Where GIF offers a single transparent color, an on or off switch, PNG introduces an alpha channel, meaning smooth transparency edges that blend cleanly against any background. A logo placed on a web page can sit over a gradient or a photograph without the jagged halos common in GIF transparency. The familiar checkerboard pattern in graphics editors when previewing a PNG file becomes shorthand, meaning the image has clean edges. PNG's compression uses a method called deflate, which carries no comparable patent burden at the time of its release. The format earns endorsement from the World Wide Web Consortium. Browser support follows, though real-world adoption is uneven at first. Early implementations handle PNG inconsistently enough that a logo can look clean in one browser and broken in another, with transparency rendered incorrectly and gamma correction ignored, the same file producing different results in different windows. A compatibility chart published in a trade magazine or developer handbook becomes a necessary reference before committing to the format. Over successive browser versions, support improves and stabilizes, and PNG begins appearing alongside GIF and JPEG in web development interoperability checklists. And yet GIF does not vanish. The reason is mechanical, rooted in how defaults harden once they take hold. A web designer building pages in the late 90s can open any image optimization tool, select GIF from the export settings panel, and know with certainty that the result will display on every browser and every platform. That guarantee, tested, proven, accumulated through years of deployment, is difficult to displace with a newer format, even a technically superior one. Tutorials reference GIF. Asset libraries are full of GIF files. Client specifications name GIF by extension. Switching costs are real, even when the alternative is free. There is also animation. GIF 89A, an updated version of the format specification, supports multiple frames stored in a single file, displayed in sequence with configurable timing and looping behavior. Standard PNG, as originally specified, handled single static images. For any late 90s use case requiring a short looping sequence, a loading indicator, a simple demonstration, or a small repeating graphic, GIF remains the only widely supported option in browsers without requiring a video player or plugin. The animated GIF becomes its own category of web content, a distinct survival path entirely outside the static image, competition with PNG. Frame strips visible in editing tools show the individual images stacked in sequence, each one a few kilobytes, the whole file compact enough to load over a slow connection. By the mid-2000s, the LZW licensing question had faded from operational relevance. Software vendors no longer needed to weigh the exposure when adding GIF support. The pressure that created PNG dissipated, but PNG itself did not retreat. It established its own installed base, its own toolchain presence, its own place in browser compatibility charts and web development handbooks. Designers working with photographic or gradient-heavy static images defaulted to PNG for its color fidelity and transparency quality. Developers shipping icon sets and interface assets chose PNG for its clean alpha edges. The two formats settled into coexistence, each anchored by different use cases, neither fully replacing the other. The visible part of a format is the file extension. The invisible part is the willingness of every tool, browser, and publisher to keep carrying it without fear. GIF lost that confidence when its compression method became a legal question. PNG gained it by making safe part of the design. What the web learned, slowly, through export dialogues and release notes, and compatibility charts and packaging decisions, is that a format becomes a standard only when every link in the chain, the encoder, the decoder, the distributor, the platform, can handle it without hesitation. The file extension is the last thing anyone sees. The economics underneath determine whether it arrives at all.